Alright, welcome back everybody. This video covers the Day 12 Vocabulary and Angles Quiz Review. In numbers 1 through 8, we are identifying the following points, segments, or lines with the appropriate term. Alright, number 1 is line HF, and line HF is a line that passes through 2 points on the circle, so that is a secant. Number 2 is point B, and point B is the center of this circle. Number 3, line DL. Line DL is a tangent to this circle, and it's also a tangent to this circle, so we say this is a common interior tangent. Point J is the point where this line is tangent to the circle, so point J is called a point of tangency. Number 5 is a segment IE. Segment IE has 2 endpoints that are on the circle, so that is a chord. Line CJ is tangent to this circle at C, and it's also tangent to this circle at J, and it's outside the circle, so we say that CJ is a common exterior tangent. Number 7 says, is LKJ major, minor, or a semicircle? From L to K to J, that's more than half of a circle, so that is a major arc. And number 8 is GEC, a major arc, minor arc, or a semicircle, starting from G, going through E, and stopping at C. That is half of a circle, so that is a semicircle. For number 9, determine whether AB is tangent to circle P. The answer is no, because when you put these numbers in the Pythagorean theorem, that's 5, 8, and 11, it is not equal. 5 squared plus 8 squared does not equal 11 squared. So the answer is no, this is not a right triangle, which means this is not a tangent. For number 10, the question is AB a tangent? The answer is yes, because the numbers 7, 24, and 25 satisfy the Pythagorean theorem. 7 squared plus 24 squared does equal 25 squared. So AB is a tangent. For number 11, it says to solve for x. And it also says that segments that appear to be tangent are tangent. So we're assuming that the side labeled as 12 is a tangent, and therefore we do have a right triangle, and therefore this fits into the Pythagorean theorem. So we can say that 7 squared plus 12 squared is equal to x squared. 7 squared plus 12 squared adds up to 193, and then we take the square root of 193 to get x equals 13.89. For number 12, we assume the side labeled x is a tangent, and therefore we can use the Pythagorean theorem. So we know that 10 squared plus x squared equals 25 squared. That means x squared is going to be 525, and then when you take the square root, you get 22.913. All right, before we do numbers 13 through 18, let's write in the missing angles in this circle. First, we know that this angle is 55 because it's the vertical angle to the other 55. Remember, vertical angles are equal. Now we can figure out that this angle here is 35 degrees because all 3 angles form a semicircle. So 90 plus 55 plus whatever this angle is has to add up to 180, and therefore this is 35. Likewise, we figure out that this angle here is 125 because 125 plus the 55 makes a semicircle, which means they add up to 180. So this angle here is 125. All right, now that we know all of these angles, we can begin answering questions 13 through 18. All right, number 13 is asking for the measure of arc ET. Now arc ET, the measure of that arc is the same as the measure of its central angle, which is 55 degrees, so therefore the measure of arc ET is 55 degrees. Number 14, the measure of arc SF is the same as its central angle, and the central angle is 35 degrees, so the measure of arc SF is 35 degrees. Number 15, the measure of angle EMS. Well, here's E, M, and S. Angle EMS takes up the 55 and the 90 together. So 55 plus 90 is 145. And that's the answer for number 15. All right, number 16 is asking for the measure of arc TFE. Arc TFE is this major arc that's highlighted in purple. It is almost a full circle. As a matter of fact, it's short of a full circle by this gap right in here, which is 55 degrees. So you simply subtract 55 degrees from 360 and you get 305. All right, number 17 is asking for angle SMU. All right, SMU is this angle here, and that is 35 plus the 55, and that makes 90. And 18 is asking for the measure of angle EMU, and EMU is this angle here, and that is 125 degrees. All right, here's number 19. It says point I is the end center of triangle ABC. So the end center is point I, which means it's the center of a circle that is inscribed into this triangle. That simply means that each of the sides of the triangle are tangents to the circle. So question A, which segments are congruent? Justify your response. Well, because I is an end center, the radius from I to E is the same as the radius from I to F, which is the same as the radius from I to D. So those are the three segments that are congruent: DI, IF, and IE. And it's because they are all radii of this circle. All right, in B it says, given that the measure of angle BAC is 44 degrees and that AD is 4.2 centimeters, find the length of DI. Well, DI is this radius here, but it is also opposite of this angle. Now this angle happens to be 22 degrees, and we get that because this angle is half of angle BAC, which was 44. So half of 44 is 22. Now the side across from 22 is DI, which is the opposite side. The 4.2 is the adjacent side. So we can use tangent to find the missing side DI. So the tangent of 22 is opposite over adjacent, or DI over 4.2, multiplied by 4.2, so DI is 4.2 multiplied by the tangent of 22, and your calculator will give you 1.697. All right, for number 20, it says point J is the circumcenter of the triangle XYZ. The circumcenter is J. That means it's the center of a circle that circumscribes the triangle, meaning that the circle touches each one of the corners of this triangle. It touches corner X, touches corner Y, and it touches corner Z. That would also mean that segment JX is a radius, and segment JY is a radius, and segment JZ is a radius. So those all radii are congruent. They're equal. So XJ and YJ and ZJ are equal because they are all radiuses or radii of the circumscribed circle. And part B, given that XY is 14 inches and that UJ is 10 inches, find the length of JZ. Now first, I would like to say that JZ is a radius and JX is a radius, so JZ is the same as JX. Now let's focus on this purple triangle. Remember it said XY was 14, so that means XU is going to be half of 14, which is 7. It also said that UJ is 10. So we have 7 and 10, and then XJ is the hypotenuse. So we can put that into the Pythagorean theorem. So JZ squared plus 7 squared equals 10 squared, and it ends up being that JZ is 12.2. Number 21, if a real estate developer wants a movie theater to be equidistant from busy town, lazy town, and crazy town, should he use the circumcenter or the end center? Well, we need a point that's equidistant from each one of the corners. That means we need a circle that's going to circumscribe or go around the circle. That means we need the circumcenter. We want the points, the center, to be equidistant to each one of the corners, or to each one of the vertices. All right, in number 22, basically we see a picture here that represents a lawn that's in the shape of a triangle. We want to place a sprinkler in this lawn such that the sprinkler will go around and water the lawn without watering any of the sidewalks. So therefore, we need the end center. It needs to be a sprinkler that will go around and go right up to the edge of the sidewalks, but not touching the sidewalks. So the answer here is that we want the end center. All right, for 23, we want to find the measure of the indicated angle or arc. Here we're trying to find the measure of arc AC. Well, arc AC is the same as the central angle here, and we can discover that the central angle has to be 75, because that is the difference between 135, 150, and 360. So that central angle is 75, therefore arc AC is also 75. All right, in number 24, we're trying to find the measure of angle QRS, which is this marked angle here. Now we know that this marked angle inside the circle is half of the two intercepted arcs. So that's half of angle 20, or arc 20, plus arc 85. 20 plus 85 is 105, and half of that is 52.5. So the measure of angle QRS is 52.5. All right, for number 25, the first thing is to write in this missing arc here. Now we know this arc is 40, this arc is 80, this arc over here is 120, so what's left to make 360 is the arc here, which is 120. Now we're trying to find the measure of angle P. Angle P is the marked angle here, and we know the formula for that is that the measure of angle P is half the measure of the big arc, the big intercepted arc, minus the small intercepted arc. So the big intercepted arc is 120, the small is 40, so that's half of 120 minus 40, and 120 minus 40 is 80, and half of 80 is 40 degrees. All right, first, let's write in the missing arc around this circle. We know that this arc here is 110, this arc is 60, and so if you subtract both of these from 360, that leaves you with 190. All right, we're trying to find the measure of angle FED, which is this marked angle. This angle is an inscribed angle, and an inscribed angle is half of its intercepted arc. So half of 190 is 95. Okay, we're trying to find X, and we know that this angle is an inscribed angle, which is half of the intercepted arc. The intercepted arc is a semicircle, so that means that this is 180 degrees, and half of 180 is 90. So this inscribed angle must be 90. So we say 2x plus 10 equals 90. Subtracting 10, we get 2x is 80. Divide by 2, we get x is 40. In number 28, we're trying to find the measure of arc LM, which is the purple arc. Arc LM is the same as the central angle. The central angle is 4x, and arc LM is 3x plus 40. So they must be equal to each other. So we set up the equation that 4x is equal to 3x plus 40. When you subtract 3x from both sides, you get x is equal to 40. Now we can plug that back in to find the measure of arc LM. Since arc LM is 3x plus 40, we can say that it is 3 times 40 plus 40, which is 160. Number 29, we want to find x. Now 5x is this interior angle, and the rule is that this interior angle is half of the two intercepted arcs. That's 80 and 70. So we can say that the angle 5x is half of 80 plus 70. Multiply both sides by 2, and we get 10x is equal to 80 plus 70, which is 150, and then divide by 10, so x is 15. All right, for number 30, ultimately we want to know the measure of arc YW. So first, we know that the angle 44 is half of the difference of 3x plus 1 and x minus 3. So we set up the equation that 44 is half of 3x plus 1 take away x minus 3. Multiply by 2 on both sides, and we get 88 equals 2x plus 4. And of course, the 2x plus 4 comes by simplifying this expression and combining like terms. So now we subtract 4 from both sides. So 2x is 84, and then divide by 2, x is 42. Now the measure of YW is x minus 3. We plug in 42 for x, and we get 42 minus 3 is 39 for our final answer. All right, for number 31, it says, what is the measure of arc ADC? Now there are several steps involved, so we just sectioned them off. Here's section A, or step A. In step A, we recognize that this is a quadrilateral inscribed in a circle, and we know that opposite angles add up to 180. So we can say that 20x plus 20y equals 180, and that's what we have here on this line. Likewise, we can say that 24x plus 15y is also 180, and that's what we have on this line. Now we have a system of equations, and you remember from Algebra 1 how to solve a system of equations. We're going to make this a little easier by making the numbers smaller by dividing by common factors. For instance, we can divide the first line by 20, and that results in the equation x plus y equals 9. We can divide the second equation by 3, and that results in 8x plus 5y equals 60. Now, we want to solve this by elimination. So I want to make the y become a negative 5y so that it will cancel with the 5y here. To make that happen, I multiply this line, this equation, by negative 5. The result is negative 5x minus 5y equals negative 45. The negative 5y and the positive 5y cancel out. Negative 5 plus 8 is positive 3x, and negative 45 plus 60 is positive 15. If 3x is equal to 15, then x is going to be 5. In the next step, we can solve for y. We can say that x plus y is 9, that was from this equation up here, and replace x with 5. So 5 plus y equals 9, and that means y is 4. That takes us over to step G, finding the measure of ADC. Now the measure of ADC is this arc right here. That is, arc ADC is this purple angle, and that purple arc, and that purple arc is twice as much as this inscribed angle here, which is 20x. So we can simply say that the measure of arc ADC is twice 20x. So 2 times 20x becomes 2 times 20 multiplied by 5, because remember x was 5. 20 times 5 is 100, and 2 times 100 is 200. And that is the measure of arc ADC. All right, for number 32, we're finding the measure of angle W. Now, angle W is this marked angle here. First, let's acknowledge that this orange arc is a semicircle. That means it's 180 degrees. It's also one of the intercepted arcs of this angle W. The other intercepted arc is 86. We use the formula that angle W is half the measure of the difference of the two arcs. So that's half of 180 minus 86. 180 minus 86 is 94, and half of 94 is 47. So that's the measure of angle W. For number 33, we want to find x. Now, there's not enough information to find x just yet. We actually need to figure out the measure of this small angle here, or this small arc here. We're going to call it y. Now we see that this is 75 degrees, that's an interior angle, And we know that this angle 75 is half the sum of these two arcs. So that means that 75 is half of 3x plus the y. We set up that equation, and then we multiply by 2 here, and we get 3x plus y equals 2 times 75, which is 150. That's going to be one of the equations that we're going to use. The second equation comes from the outside of angle 45. We know that angle 45 is half the difference of the two intercepted arcs. So that means that 45 is half of 3x minus y. Multiply both sides by 2, and we get 3x minus y is 90. So we have these two equations where the check marks are. We're going to put these two equations together and solve that system of equations. So down here, we have that 3x plus y is 150 and 3x minus y is 90. We can add these two equations and the y's cancel out, giving us 6 times x equals 260. Dividing by 6, we get x is 43.3. In number 34, we're solving for x. Now before we do that, first let's acknowledge a couple of things. We have this inscribed angle, which is 72, and we know that this arc, the intercepted arc, is twice as 72, so this arc is 144. Likewise, we can acknowledge that the blue arc, which is the remaining arc from the 360, is 216. That's 360 minus 144, gives us 216. Now we have the blue arc and we have this brown arc. The angle out here, 8x, is half the difference of these two arcs. So we can set up the equation that 8x is 1/2 of 216 minus 144. Multiplying by 2, we get 16x, and then over here we have 216 minus 144 is 72. And then we just divide by 16, and x is 4.5. Alright, this concludes the video on the angles quiz review. I hope you found this helpful.